All right, guys. So looking at exponential form of a complex number, z is equal to x plus iy is the same as saying r into cos theta plus I sine theta, which is the same as saying r e to the I theta. So z is equal to r e to the I theta is called the exponential form of a complex number, where r is the modulus and theta is the argument. So we're now asked to write the complex number z. This is example 23 is equal to 1 plus I in the form r e to the I theta, where r is the modulus of the complex number and theta is the argument. So in order to accomplish this, I must find the modulus of z and the argument of z. So now r, the modulus of z, is equal to the square root of real, which is 1 square, plus the imaginary square, which is also 1 square. So this is equal to the square root of 2. Now the argument of z, theta, is equal to tan inverse one imaginary 1 over real 1. Now 1 is in the first quadrant, so the argument, remember that in the first quadrant and in the fourth quadrant, the argument is simply tan inverse imaginary over real. So here the argument is pi by 4. Argument is always measured in radians, so it's pi by 4. And so now we can see the complex number z, which is 1 plus I, can be written as r, which is what, root 2, e to the argument, to the theta I, or I theta. So it's pi by 4, which is the argument I. All right, that is simple, it's done. Now I want you to try example 24.
So, quick question, what does the E represent overall?
The E. E is a constant. I think it's 2.7 something. I don't remember the exact value of it, but E is a constant. Here's what I would say to you, Amali. Let us go through the process of learning this now, and then we can deal with what is E now, what is E after that. But E is a constant. Just like pi, like pi is 3.14, E is a constant which have a value which is 2 point something. I don't remember exactly what it is. But go through the process now of learning it, and then we can address what is E. All right, guys, please try example 24. All right, so the complex number z is equal to root 3 plus I, the argument, the modulus, first, the modulus of z is equal to the square root of root 3 squared plus 1 squared. So this becomes the square root of 3 plus 1. So that's the square root of 4, which is 2. So the modulus is 2. Root 3 squared is 3, because root 3 squared means root 3 multiplied by root 3. So that is 3. 3 plus 1 is 4. The square root of 4 is 2. The argument of z, this is root 3. The coordinate here is root 3, 1, which is, once both are positive, it's still first quadrant. So this is tan inverse, imaginary, which is 1 over root 3. All right, 1 over root 3. Let us see which angle this is. I'm just picturing it in my mind's eye. 1 over root 3, that's a tan of 30 degrees. So the angle here is that the argument here is 30 degrees, which is pi by 6. So this means that the complex number z, which is root 3 plus I, in polar form is 2e to the pi by 6 I. All right, did you get this, guys? No. All right, so the question asks for two things. It asks for the exponential form and it asks for the polar form. So the polar form is z is equal to r, which is 2. The cosine of the argument, which is pi by 6, plus I sine pi by 6. All right, so this would be the polar form, and z is equal to 2e to the pi by 6i would be the exponential form. So here we have z. All right, let's change the color ink. We have z is equal to 1 plus I over 1 minus I. I'm going to multiply the numerator and the denominator by the conjugate of the denominator, which is 1 plus I. 1 plus I. I think this is something that we've probably done already. Up top, we're going to get, so this is 1 plus 2I plus I squared. That's up top. Down by the bottom, we're going to get 1 minus I squared. All right, so up top, we're going to have 1, I squared is minus 1, so 1 minus 1 is 0. So at the top, I'm just left with 2I. And at the bottom, I have 1 minus I squared. So I squared is minus 1. So this is 1 minus minus 1, which is 1 plus 1. So it's 2. So it means that z is equal to I. Now, if z is equal to I, it means that the argument of z is 90 degrees, or pi by 2. The argument is pi by 2. Sorry. All right. The modulus is actually 1. The modulus is 1, and the argument of z is equal to pi by 2. Everybody clear on how I got those? I'm going to represent I for you on an Argand diagram. I'm going to represent I for you on an Argand diagram. This is my Argand diagram. This is imaginary. And this is real. All right. So over here, so this is 1. This would be I on an Argand diagram. That is I. Or if you want, this is I. I change the color ink for emphasis. This is I. That is I. Now, if you remember that the argument is measured from the positive real axis, so this would be the argument, and the argument is 90 degrees. This would be the argument, and that argument is 90 degrees. And the modulus would be the length, and the length is 1. So the modulus is 1, and the argument is pi by 2, which is 90 degrees. So it means, therefore, that Z, let's start with Z first. Z is actually equal to 0 plus I, that is in Cartesian form. B, in polar form, Z would be equal to 1 cos the argument, which is pi by 2, plus I sine pi by 2. So that is in polar form. And C now in exponential form, Z Z would be equal to E pi over 2 pi. Any problems, guys?